Welcome to the Bentech 7X Assembly Panel Tutorial. Before we start, we're going to go over some things that all of our customers should come to understand in order to use their software efficiently. The display area shows what we call a TriStar, which is used as a directional guide and starting point for most projects. The directions are defined as left, right, front, back, ceiling, and floor. Compared to the XYZ directional, this seems to be an easier concept for most people to understand. However, if you're used to having it another way, you can always change the look of the TriStar in the settings section if that makes you more comfortable. PickPoints are used for everything. So what are they? PickPoints are simply points in 3D space created by the user that are meant to define where the parts in the project will be placed. Once PickPoints are placed in the display area, you can build off of them by using them as reference points for other points. Most of the time, you can think of them as the end of your tape measure. Centerline means exactly what it sounds like. Every line that you create in the Assembly Designer represents the very center of the material you're working with. Think about it like the way a wick runs through the center of a candle. The apex of the bend is really the intersection of two center lines, as if there wasn't a radius. Start by opening the Bentech software and selecting the Assembly Designer. From here, maximize the screen and select the material and die from their respective lists. In this tutorial, it doesn't matter what you choose since we're focusing on the panel feature only. Now, select the PickPoints tab to begin creating our first part. Type 24 in the ceiling field and click Apply to place the first point. Then type 32 in the ceiling field, 12 in the right field, and click Apply. Then type 24 in both the ceiling and right fields and click Apply. Now type 0 in the ceiling field, leave the 24 in the right field, and click Apply again to finish. This is the outline of our part. Now we need to connect the PickPoints by placing our straight parts. So select the Straight button and make 5 straight tubes by clicking each of the PickPoints in the display area. Remember that each point is both a starting point and an ending point for a tube. Now go to the Cutting tab and select the Auto Miter button. Miter these tubes by selecting each set of tubes that intersect each other. When you're finished, you should have 10 cuts shown in the cutting section to the left. Now, to start creating the sheet metal panel, go to the Design tab and the Panel sub-tab. From there, click the Select Tubes button and prepare to select each of the tubes. It's important to remember that while you're doing this, you'll have to click the end of each tube in succession. The panel will not define if you click the start of one tube and follow it by clicking the end of another. When you're finished, click the Complete button. You'll need to choose a material for the plate by clicking the Create Plate button. Select the material from the drop-down menu and click OK. Now the plate has been placed and is ready to be edited. As you can see, the panel covers the front side of the tubes. To begin the editing process, we will alter the way the plate wraps around the tube. So go to the Wrap section on the left-hand side and type 180 into each of the 5 value fields. This will cause the panel to wrap all the way around the back of the tube. When you're finished, press the Create Plate button. Next, we'll edit other aspects of the panel in the sheet metal plate interface. So go to the Main tab, select the panel from the master list, and click the Edit button below to send the panel out to the sheet metal interface, where we can edit the plate in more detail. In the sheet metal module, the panel will appear with the flanges directed upward, and it will appear in design mode from a bird's eye view. From here, you can create holes, text, notches, and much more. We will begin by making a few points that we'll use as references to place holes. So select the incremental option, type 12 into the Y field and select the bottom corner of the base flange located to the far right in the display area. Now, use this point as a reference for the next. Delete the 12 in the Y field and type -24 in the X field and click the new point. From there, type 1 in the X field, 1 in the Y field, and click the new point. Then type a minus sign in the X field and click the center point. Next, type a minus sign in the Y field and click our point. Finally, erase the minus sign in the X field and click the point once more to finish placing points. Now we're going to place some simple bolt holes, so go to the Holes tab and select the square option. Then type 0.5 in the width field and place 4 holes over 4 of the points as seen here. Afterward, go to the Part tab and click Define All to define the part with the new holes. A quick look under the flanges list should show all green bends and flanges. Then, with the part complete, we can export it as a Plasma DXF file, including the flats of the flanges and cutouts for the holes. Go up to the Tools tab and select the Plasma DXF Export option. A window will appear asking you to name and save the file. So name the file whatever you'd like and press the Save button. Thank you for completing our assembly panel tutorial. For more helpful and informational videos, subscribe to our YouTube channel and like us on Facebook.